All right, so this program is going to cover this 2011 number 4. It's called the route cipher program. So it says in this question you will write two methods for a class route cipher that encrypts, meaning it puts into a coded form a message by changing the order of the characters in the message. The route cipher fills a two-dimensional array with a single character substrings of the original message in row major order, encrypting the message by retrieving the single character substrings in column major order. For example, the word surprise can be encrypted using a 2-row, 4-column array as follows. So here's our 2 rows, row 0, row 1, column 0, 1, 2, and 3. And you've got SERP and then rise. That's the original string. This is what the 2D array looks like right here. And apparently when you encrypt it, that's what it comes out to be. So an incomplete implementation of the route cipher class is shown below. You got the 2D array letter block. You got a variable number of rows. That's the number of rows that you're going to have. Number of columns, number of columns. So it says, for this part A, it places a string into the letter block in row major order. If the string is less than that, so in this case it'd be 2 times 4, it would give you 8. A is placed in each unfulfilled cell. I think they give a better one. So down here, meet at noon. You've got 3 rows and 5 columns, so 15 total cells. But the length of meet at noon is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So there's 12 characters. So because the length is less than 3 times 5, which is 15, the last 3 cells in here are placed with an A, uppercase A. And that's what it's trying to say right here with the precondition. If it's greater than that, trailing characters are ignored. So that's for the fillBlock method. encryptBlock. You guys will write encryptMessage part B, but encryptBlock, I believe that we're not going to write that. You're just assuming that it's going to work okay. Let's do part A first, and before we get to B. So write the method fillBlock that fills the two-dimensional array letter block with 1 character strings from the string passed as a parameter string. The array must be filled in row major order. The first row is filled with from left to right, then the second row is filled from left to right, and so on until all the rows are filled. The length of the parameter string is smaller than, if the length of the parameter string is smaller than the number of elements of the array, the string A is placed in each of the unfulfilled cells. If the length of str is larger than the number of elements in the array, the trailing characters are blocked. For example, 3 rows, 5 columns, so meet at noon would be as follows. If letter block has 3 rows, 5 columns, and string is the string meet at midnight, so notice how the T in midnight doesn't show up, which that's no big deal, because all we do when we're working with 2D arrays, you're just going to run through it, the number of rows and the number of columns, so you won't even have to worry about cutting off the T. It will do it for you automatically. The following expression may be used to obtain a single character string at position K. All right, so that line of code will be important because this is what's going to be assigned into your row and column. So let's write part A right here. You know what, I kind of want to make this larger too. Let's change the font up a little bit. 16 is a little bit larger. Okay, so part A. So, and I remember I said that is important, that K is important. So I'm going to have an int K equal to 0. Because think about it, 0 and 0 plus 1, wouldn't that give us the M in our string substring? And then when we go through again, K would be 1 after the first time through. And so what's that position? 1, 1 plus 2, 1. And then 1 plus 1 is 2. So with a substring, that would be E, and then so on and so forth. All right. So the biggest thing to think through and to remember are how your rows and columns work. So I would say, you know, we always do rows first. So I'd say row equals 0, row is less than what? The number of rows, row plus plus. And then you got another for loop inside to deal with all the columns. So then you'd have what? Int col. Column is going to be less than num calls. So K is going to give us the position where we're at each time. And we want to be able to add up K each time to give us where we're at. But we have an issue here where K could become greater than the string. And that's where we're at, because K is going to be, you know, position 0 right here, then position 1, then 2, then 3, then 4, then 5, all the way down, right? But in this case, K would get here and it would be larger than the string, so we want to make sure that it would put an A in there, okay? So I want to have, you know, an if statement that would say if K is less than the string length, let me think here, else we do something. So if K is less than the string length, then, you know, it tells me fill your cell right here with that, okay? So M. So what do? I'd say letter block at row and then column. So at first it'd be 0, 0. That would be equal to, and like I said, use what they give you. Okay. And then we got to add up K. So at position 0, because K is originally 0, 0, and then 1, that's where you would throw the M into row 0, column 0, right? And then you'd come back up here and column would be 1. So is K, which is 1, is that less than our string, meet at midnight or whatever? Yes, it is. So then at position 1, and then 1 plus 1 is 2, that would be the E, and that gets thrown into position 0, and then column is 1. And then we would so on and so forth, okay? And it would go through all the way. Now, like I said, with this one, K, you're counting up each cell basically. K is your cell, what cell you're in. So by the time we get here, you know, K is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is not less than the string length 12, because the string length is 1, 2, 3, 4, 5, 8, 9, 10, 11, 12. Okay, so, yeah. Sorry, 13. I counted that wrong. It's not less than the length. So then we've got to do something else. And that's where we get right here. And we say what the letter block is equal to A. Letter block at the row and the column that we're at is equal to A. Okay. So that's fillBlock. So all you're doing is just filling it with your string and A otherwise. So part B, let's look at B. Ooh. Write the method encryptMessage that encrypts its string parameter message. The method builds an encrypted version of message by repeatedly calling fillBlock with consecutive non-overlapping strings of message and concatenating the results returned. So it's okay. Each fillBlock. When all of the message has been processed, the concatenating string is returned. Note that if message is the empty string, encrypted message returns an empty string. Okay, so easy points. First thing you always do what's easiest. So right here for position B, let me think here. What does it say the method or the variable is going to be called? The concatenating string is returned. Note that if the message is an empty string, encryptMessage returns an empty string. Okay. Let me look up here. Is there a variable that encryptMessage, or do I need to create it? Yeah, I gotta create it. So string encryptedMessage equals blank and return. So always do that step, you know, create your variable and then return it. Then you can come back and worry about what's going on here. The following example shows the process carried out if letter block has 2 rows. So this is where row is 2 and column is 3. You have to use, you know, what they're using. We got meet at midnight. So 2 times 3 is 6. So we can only fit, you know, 6 characters in there. So let me do this down here because this we might need to write this out a little bit. So we'll say index. And then what do we have? We've got meet at midnight. So this is 0, 1, 2, 3, 4, 5, 6. Okay, so what is it doing? So the first 6 are right there. So I don't know. I'm just gonna write first 6. This is just gonna be kind of how you're gonna think through this. All right, meet space A. 1, 2, 3, 4, 5, 6. Okay. So I don't know. Second 6. We got meet A. So 1, 2, 3, 4, 5, 6. Let me make sure. So T space mid N. And then whatever's left is I, GHT, and then so that's 1, 2, 3, 4, and then the last two would have to be A's to fill up our third 6. Okay, so meet at midnight. All right. So we will take the substring, which is going to just be the first 6, which is determined by the rows times the column, because they could change this up to have like 4 rows and 5 columns or something like that. So what do I want to call this? This would be like the first each I don't know, block or whatever. Let me think here. What do I want to call this? Int string block is going to be equal to the num rows times the num calls. The number of rows times the number of columns. Okay. So that would give us 6 right there, right? Then, so message is passed in. So, let me think here. In this example, the method returns that, assume that the fillBlock and encryptMessage. So we wrote fillBlock, and that's good. And encryptBlock work specified. Work as a specified. Solutions that re-implement the functionality of one or both of these methods will not receive. Okay, so you have to do both of them in order to get it right. Now, we're just assuming that this one works. We don't know how it works. We're just assuming it works. So we need to call it, but we don't really know how it works. Okay. So, okay, so our message gets passed in, and I guess we're just, we're going to run through this until, the message length is greater than 0, I guess. So while our message dot length is greater than 0, so so if our string block, so where am I at right here? So first of all, we got to think through, what do we do if our string block right there is greater than our message that's passed in right here. So then we'll just say it's equal to that, I guess, equal to, like in this case, 4. So we'll just say if our string block is greater than the message dot length, if that's greater than the length, then we'll just say our string block is equal to the message dot length. Okay, so that would give us 4 right here, all right? But if it's not, then all we want to do is just call our fillBlock with our message. Okay, so our message gets passed into fillBlock. Remember, fillBlock, we did up here, works, and it just fills our message that we passed into here. So it will go through, you know, 2 rows and 3 columns and fill it in. And since the first 6, you know, the length of the message is not, you know, of this K is not less than the length of our message, then, you know, it's going to fill everything in properly. And so then what do? We would just say now remember I said encryptMessage, encrypted message. That's just going to be plus equals the encrypt block. And we just assume it works properly. And now we wanted to go back up and do another message, but not do the first, you know, not do the first 6 here. We want to go to here. So we would just do, let me see here. We would just do, all right, so then what we got to do, and sorry, I had to pause the movie. I got kicked out of my room and I had to go somewhere else. So we encrypted the message and we passed our, we're building this new encrypted message by concatenating the encrypt block. So then, which we just assume that works. And then, so then we've got to, we just did the first, 6. So then what do we got a substring from here on. So then all we do is just say message equals the message, dot substring, and then our string block. Because our string block is 6, right? And I think that works. So our message is greater than 0. Okay, our message originally was this. That's greater than 0. If the string block is greater than the message length, which it's not the first 2 times, but the third one it is, so we would just set that equal to 4 right there instead of being 6. We fillBlock, so we pass in our message into the fillBlock, which would create, you know, this first one, MEET space A. Then we just create this encrypted message that we assume that encrypt block works, and they tell us to use it, so we have to use it. And then we just, you know, create a new message without this, and so now we pass in, this would be what? T to midnight, so T space midnight. So that would be the new message, and that gets passed in, so the length of that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10. String block isn't greater than 10, so we skip that. We pass the message in. That gives us T space MIDN. And then we run this encrypted message again and concatenate it from encrypt block. And then this becomes what? String block is 6 again on this, so let's write this out real quick, because what would it become? It would become T space MIDN IGHT, right? So then the first, so substring at 6 right here would be just those three, right? So if IGHT gets passed into here, that's greater than 0. The string block is greater than 4, so that would be 4. We pass 4 into the message in here, IGHT, it becomes that, you know, IGHTAA. We do our encrypt blocked again, and then 4 would be our string block here. So sorry, and then this would be IGHT. Okay. And then what do we got here? So starting at position 4, there's nothing at position 4 right here, so we don't have a new message. It's blank, so is that greater than 0? No, and so you're done, and so then you return the encrypted message. So this one's a little bit tricky right here. That would be hard to think through on the fly. I don't like the ones where they just assume that it works and you don't get to see what's happening, but whatever. I don't know. So let's look at, you know, the answer for A, fillBlock. It says it copies at least one substring from the parameter. So, you know, kids may get mixed up and do just an array and not a 2D array. Completely fills. No out of bounds. So the importance of the out of bounds is what, this right here for A. So you must know how, in order to do well on this test, you must know how to do rows and columns for a 2D array. So that's a full point, you know, if you do all of them with no out of bounds. Results in a distribution of all consecutive characters to that, ignores the surplus. So that would be like if you did that would be like for A, if you did this right here, but you didn't do these ones, all the A's, okay? Again, do what you know how to do. If you don't know how to get these A's in there, then at least just get that in there, okay? Because that would give you, you know, again, that's going to give you that point. Copies these one character substrings from parameter to letter block in such a way that the result is in row major order. Well, that's what you would do if you did the rows first and the columns first, the columns second, with your 2D array, your nested for loops. So again, like, that's not too hard. The hardest part about A is kind of figuring out this right there, the K stuff, and then that right there. This is actually kind of difficult to think through on the fly. But if you don't get the A section right, you only miss a point, you know? So that's not that big a deal. So the first one's 3.5 points. You get 2.5 points right there. You're doing okay. So part B, do you return resulting build string? You know, that's where I told you guys, get your easy points, you know? Create your encrypted string, return it. Return the empty string if the parameter is the empty string. So that's, you know, part of returning this. So that's creating a blank string. Creates a substring of parameter that progresses through the parameter string, can overlap or skip. Process every character in parameter. No bounds errors. So that's this right here, I believe. You're processing through the strings with no out of bounds errors. Invokes fillBlock. You know, we invoke fillBlock right there. That seems pretty easy. Just call fillBlock. Invoke fillBlock on more than one substring. So that's where if you don't get your loop, if you were just to do like that right there, and then call fillBlock, and then call encryptBlock, you would only get half a point because you'd only done it one time, not all the time. So this makes sure that you do it for all of them after each. So you have to do it on each for that. Concatenate, build, return. So anyway, this video's done.